All right, let's take a look at a couple of drawings very similar to the ones that we made in class together. Here's what we have going on here, just to point out a couple of things. Here's our sun, and the sun is going to be kicking out light here going from left to right, which makes this the daytime side of Earth, and it makes this the nighttime side of Earth. And I also labeled the umbra right here, or the Earth's shadow, and I showed the path of the moon's revolution going around the Earth. And so if I grab my moon here, we're going to have the moon cruising around the Earth, and this takes a month to go from here all the way back to here. Now as the moon cruises around the Earth, if the moon cruises into the shadow of the Earth, or into the umbra of the Earth, then we will get a lunar eclipse. Now, again, this is only if the Earth, the Sun, and the Moon are on the same plane. If the Moon or the Earth are not on the same plane, if they're not in a straight line, then this won't happen. And if we take a look here, here is this person smiling. They're on the nighttime side of Earth, and they can see the Moon. This will be true of anybody that is on the nighttime side of the Earth. Anybody that's on the nighttime side of the Earth that can see the Moon will see this lunar eclipse. Anybody on the daytime side of Earth, well, they're not going to be so happy because they won't be able to see the eclipse. What they're going to be looking at is, well, they're going to be looking at the sun. It'll be daytime for them. They won't be able to see the moon because it's happening on the other side of the Earth. Now, how long does this take? Well, it takes the moon about an hour or so to completely pass through this umbra. The whole process takes about 3 hours. It takes about an hour to go into the umbra. Then it spends about an hour in the umbra, and then it takes an hour to get out. But the total lunar phase will take about an hour to pass through that umbra. So, why do we get lunar eclipses? Well, we get lunar eclipses because the moon passes through Earth's shadow, or Earth's umbra. What phase does this happen during? Well, it happens during a full moon phase. That's when the moon is on the other side of the Earth opposite the sun. Who can see it? Anyone on the nighttime side of Earth can see it. How long will it last? Well, it'll last for about an hour, meaning the time that the moon is in the shadow of the Earth will take about an hour. Here's the setup for the solar eclipse. We have the same exact setup, where we have the Earth here, there's the daytime side, the nighttime side. I put a couple people there. Person on the daytime side is happy because they're going to be able to see the eclipse. The person on the nighttime side is not happy because they won't see the eclipse. I have the moon's revolution path right here. I got the moon hanging out over here. And we got the sun kicking out some light that way. So let's grab that moon and see what happens here. Here's our moon. It's following along in its path. It's going around, it's going around, it's going around. And here's our solar eclipse. A solar eclipse is going to happen when a person on Earth is inside the moon's umbra. And what they'll see, even though the sun is so much bigger than the moon, because the moon is so far away, they'll actually see the moon and the sun to be the same exact size. And the moon will cover the sun, producing that solar eclipse. But again, only people that are in that umbra will be able to see it. So if you had people outside of the umbra over here, or people outside of the umbra over here, they won't see the eclipse. It's only people inside the umbra. But as the Earth rotates, then different people on Earth will be able to see the solar eclipse as long as they're within that umbra path. So, why do we get solar eclipses? Well, we get solar eclipses because the moon blocks out the sun. But the person that's looking at the sun, the observer that's looking at the sun, they also have to be in the moon's umbra. What happens? What phase does this happen in? Well, this happens during our new moon. Who can see it? Well, only people that are in the moon's umbra on the daytime side of Earth can see it. And how long does it last? Well, it lasts just a few minutes. The moon's umbra is small, and the Earth rotates pretty fast. So somebody that's in that umbra, as the Earth turns, the spinning Earth is going to take them out of that umbra really quickly. So you'll only see it last for just a couple of minutes. Now, one more point here. We talked about what an annular eclipse was. Annular eclipse, here's the idea. Here's the moon. and the moon is a little bit further away. The moon's just a little bit further away in its orbit. We discussed that as being the apogee point, or the further away point. Now here's what happens. Because the moon is a little bit further away, it appears to be smaller, and it cannot completely cover the sun. So what winds up happening is this. Is somebody looking at the solar eclipse from Earth? They'll see the moon covering the sun, but it won't completely cover it. And they call this an annular eclipse. An annular eclipse is when there's a solar eclipse, but there's a ring of the sun left around the moon, an annual or a ring. So here's a question. If we have a full moon every month, and if we have a new moon every month, how come we don't get eclipses every month? We always have a new moon, we always have a full moon, at least once per month. Wouldn't it make sense that we would get a lunar eclipse with every full moon? And wouldn't it make sense that we would get a solar eclipse with every new moon? We don't get eclipses every month because the moon's revolution as it goes around the Earth is tilted. It's off axis by about 5 degrees. And in order for us to get eclipses, they all have to be lined up on the same plane. Let's take a look at a couple of these diagrams to understand that a little bit here. When I take a look at this diagram here, let's take a look at this plane right here. We can see there's a little lift right here. That's representing that 5-degree lift, or that 5-degree tilt. And if we get a new moon when the moon is at the maximum of that tilt, then the umbra of the moon will miss the Earth, and we won't get a solar eclipse. Or, on the other side, if we get a full moon when the moon is at the minimum of that angle, or at the bottom of it, then it will be below the Earth's umbra, and we won't get a lunar eclipse. Now we can take a look at this diagram, and it will show the same exact thing here. That here, the new moon is below the Earth, and then here the full moon is above the Earth. And what we kind of need to picture here is that there's another line here, and this is lifted up by about 5 degrees, bringing that full moon above the Earth's umbra, preventing us from seeing the lunar eclipse. Or bringing that new moon below the Earth, so its umbra can't reach the Earth, and we won't get a solar eclipse. It's only when they're all on the same plane. It's when they're at a node where they're all on the same plane and in a line that you'll get an eclipse. Here we have the new moon lined up with the Earth on the same plane. An observer on Earth will be in the moon's umbra and will see a solar eclipse. And over here, if it's happening at night and we have our full moon phase, anybody standing here on Earth on the nighttime side, they'll be able to see the lunar eclipse as the moon passes through the Earth's umbra. And we can see that again in this diagram right here. It's showing that 5-degree tilt. If we're at a point when the objects involved are all on the same plane, then you'll get an eclipse. But a lot has to happen. They all have to be on the same plane, and the right phase of the moon has to happen. And that's why eclipses don't happen very often, because you have to have those conditions met before you can even begin to have an eclipse. Then you have to have good weather. But that's a different story. I hope this video helped you out. If you have any questions, please ask me in class.